Hello! In this video, we are going to prove the following lemma. Suppose R is a relation from A to B. Then for all objects x and y, we have that the ordered pair x comma y is an element of R if and only if the ordered pair y comma x is an element of R inverse. Alright, now the book we're working off of is Daniel Velleman's How to Prove It book. And the way he defines the inverse of a relation is as follows. So let's say that we have some relation R from A to B. That's the same thing as saying R is a subset of A times B. Well, then the inverse of R is defined as the set of all ordered pairs Q comma P in B times A, such that P comma Q is an element of R. Right, so that's essentially the idea. Now, we're going to prove that this statement is true. Right, so to start our proof, let's suppose that we already have been given a relation R from A to B. And from here, we want to prove for all objects x and y that this is true. And since we're trying to prove a statement about every two objects, give me any two objects. I'll call them x and y. And we're trying to prove a statement containing if and only if. So what we can do is we can prove if this is true, then this is true. And if this is true, then this is true. Let's start by proving if this is true, then this is true. And to do that, suppose this is true. Now, since R is a subset of A times B, this means that everything in R is also in A times B. So, since x comma y is an element of R, we have that x comma y is also an element of A times B. And if you recall, when we have an ordered pair in a Cartesian product, this means that the first coordinate is an element of the first set, and the second coordinate is an element of the second set. So really, we have that x is an element of A, and y is an element of B. And from the observation that y is an element of B and x is an element of A, we have that the ordered pair y comma x is an element of B times A. So notice we have that y comma x is an element of B times A, and x comma y is an element of R. So, the ordered pair y comma x satisfies all the requirements to be an element of R inverse, right? It's an element of B times A, and when you swap the order of x and y, you obtain that this is an element of R. So yeah, y comma x is an element of R inverse. So, from our assumption that x comma y is an element of R, it follows that y comma x is an element of R inverse. So we have proven if this is true, then this is true. Now we're going to prove if this is true, then this is true. And to do that, assume this is true. Now, what does this mean? Well, by definition of R inverse, it means that y comma x is an element of B times A. And if you swap the order of x and y, you have that x comma y is an element of R. So we have that x comma y is an element of R. And that's exactly what we wanted, right? From our assumption that y comma x is an element of R inverse, we obtain that x comma y is an element of R. So we've proven if this is true, then this is true. And we've proven both directions of the if and only if. So we've proven precisely this statement. Since x and y were arbitrary, this means for all objects, x and y, this statement is true. And that's exactly what we wanted to prove, so this completes the proof. And so yeah, that's pretty much it for this video.